In this video, we are going to go over Lewis structures. So a Lewis structure is a representation of a compound using the electrons which formed it together with the electrons which didn't participate in a chemical bonding. So let's start with hydrogen gas. So H2, what is the Lewis structure of H2? So the first thing is we need to understand how many electrons are there. So each hydrogen has got only one electron, but there are the two of them. So only two electrons are here. So these two electrons are the ones which will be distributed. So we are going to draw one hydrogen and then another hydrogen. So we have that hydrogen like that, even this one. So actually only these two are going to come together to form a hydrogen molecule, which we can show like this, or simply because two electrons they form a bond, one bond, we can also write it like that. So this is the Lewis structure for hydrogen, one of them, any of them. So let's talk about oxygen gas. We see what happens. Now perhaps we need to understand something. When you go in on the periodic table, group 1 elements such as beryllium, they lose the group 1 element starts beryllium is not in group 1, so let's start with hydrogen. Hydrogen can gain or lose the one electron, and so it can form one bond because it's in group 1. Beryllium is in group 2, and so it can lose the two electrons, so it can form two bonds. If we go to boron in group 3, it can lose the 3 electrons, so it can form 3 bonds. If we go to carbon, which is in group 4, it can form 4 bonds either by losing the 4 electrons or by gaining 4 more. If we go to nitrogen in group 5, it needs 3 more electrons to be stable, so it can form 3 bonds. If we go to oxygen in group 6, it has 6 electrons in the outermost shell, so it can lose 2 electrons. It can gain 2 electrons to be stable, so it forms 2 bonds. And then fluorine, which is in group 7, only needs 1 electron, and so it forms 1 bond. So this knowledge is very important when we are writing even Lewis structures. So the first thing is we have got our 2 oxygen atoms. Now we need to understand how many electrons are there. So there are the 2 of them. Each oxygen has got how many valence electrons? So what we are interested in are valence electrons in the outermost shell. So each oxygen is in group 6. An oxygen is in group 6, so it has got 6 electrons in the outermost shell, giving us 12 electrons. So if you want to draw the Lewis structure, the first thing is draw a single bond there. So from the 12 electrons, if we draw a single bond has got 2 electrons. Okay, just like this bond which was here formed a single bond. The single bond has 2 electrons. So what we are going to have is, from the 12 we have remained with 10. So these 10 we can distribute them equally. 5, let's put 5 on this one oxygen, and then 5 also on this one oxygen. Now we need to make sure that the octet is achieved. 8 electrons on each oxygen. So if we consider this one which is here, how many electrons are here? 1, 2. So we've got 2 there, 4, 5, 6 in this bond, and then 7 that one. If we come to this one, 1, 2, 3, 4, 5, 6, 7 in the bond. So none of the high oxygens are stable. So now because none is stable, and we know that oxygen is able to form a double bond, we can bring this one electron which is here and this one electron which is here to form another bond. And so now these 2 electrons which were here will no longer be there. So now let's see how many electrons are there in each oxygen. So this oxygen has got 4, 6, 7, 8. Sorry, this is 2, 4 here, and then 6, the one I've pointed there, then 7, 8. We come to this one, 2, 4, 6, 7, 8. So now each oxygen has got 8 electrons in the outermost shell, and therefore the Lewis structure for oxygen is supposed to have a double bond. So that is the Lewis structure for oxygen gas. Let's talk about this compound, methane. So carbon has got 4 electrons in the outermost shell, and then plus we have got 4 hydrogens, each having only 1 electron. So the valence electrons are 8. So it is this 8 which will be distributed among these atoms. Now, because we only have 1 carbon and 4 hydrogens, the carbon which is alone becomes the central atom, and then the others will be around it. So these will be around the carbon, like that. So already the bonds are formed. We have got 2, 4 there, 6 there, and 8. All the 8 electrons are done. And we know carbon is balanced because it has got 8 electrons, and each hydrogen is only supposed to have 2 electrons. This bond has 2 electrons, 2, 2, and also that one 2. So therefore that is the right Lewis structure for methane. Let's try ammonia, NH3. How many electrons are here? So nitrogen is in group 5, so it has got 5 electrons in the outermost shell, and then we've got 3 hydrogens each having only 1 electron in the outermost shell, giving us 8 electrons to be shared in the outermost shell. So because nitrogen is just alone, nitrogen is going to be like that, and then is going to form bonds with the hydrogens like that. Already each single bond that we have formed, 2 electrons, 2 electrons, 2 electrons, taking 6 electrons. But you already know that hydrogen is already balanced. Like each hydrogen only needs 2 electrons, so they are already balanced. Okay. Now from this, we've already used up 6 in those 3 bonds. We are remaining with 2 electrons. If you consider nitrogen, it has got only 2, 4, 6 electrons. So for it to be balanced, it needs 2 more. So now those 2 are going to come here as a lone pair. So we call that a lone pair because it hasn't reacted with anything. So therefore ammonia has got 1 lone pair. We say 1 lone pair because it has got 2 electrons which have not participated, and we call it a pair. That is because there are the 2 of them. Okay. Now there is also a formula that we can use to calculate the number of lone pairs on an atom. So number of lone pairs is equal to group number minus electrons shared divided by 2. So that's the formula that we can use. For example, if we are talking about nitrogen, nitrogen is in group 5. So that is 5 minus how many electrons has the nitrogen shared. So as you can see, it has made 3 bonds. So it has shared how many electrons? 3 with each hydrogen. And then divided by 2. 5 minus 3 is 2. 2 over 2 is 1. So nitrogen in ammonia has got 1 lone pair. And we know that a lone pair has got how many electrons? That is 2 electrons. Okay. We can talk about another compound. Let's say water. So the first thing we need to find out how many electrons are here. We've got 2 hydrogen each with only 1 electron in the outermost shell, and then 6 electrons in the outermost shell for oxygen, giving us 8 valence electrons. Okay, electrons which will be found in the outermost shell. Because oxygen is just alone, it becomes a central atom. And then we are going to have the 2 hydrogens there. Now already this bond has got 2 electrons, this bond has got 2 electrons, making 4 electrons already out. So from the 8 we've removed 4, 4 are remaining. And as we can see, the hydrogens are already balanced because they already have 2 electrons. So the 4 which are remaining will come on oxygen, like that. So this is the Lewis structure for oxygen. Now, how do we calculate the lone pairs? We know, of course, it has got 2 lone pairs, 1 and 2. So we can actually calculate lone pair is equal to group number so that is group number minus electrons shared divided by 2. So oxygen is in group 6. It has shared how many electrons? 1 here, 1 there. It has only shared 2 electrons, and then divided by 2. 6 minus 2 is 4. That is over 2. That is 2. So oxygen has got 2 lone pairs, even as we can confirm. Okay. So let's talk about another compound. So maybe we can go to some compounds which are exceptions to the octet. So there are some compounds which do not obey the octet rule. The octet rule says an atom other than that one which is in group 1 is supposed to have 8 electrons in the outermost shell to be balanced. But there are some atoms which don't obey the octet, like group 2, period 2 elements can have few electrons. Okay, can have less electrons other than 8 in the outermost shell. And then starting from period 3, going all the way to the down periods, like period 4, period 5, they have an expanded octet. That is meaning they can have more than 8 electrons in their outermost shells. So let's look at some examples. We see how we can write the Lewis structures for such. Okay. So, for example, let's talk of this compound, BH3. So, boron has got 5 electrons in the outermost shell, and then reacting with 3 hydrogen each with only 1 electron. So, this is giving us 8 electrons to be shared. But if you draw boron, I don't know if we can call it boron trihyd. I don't know the name we can call it, what they call it. So BH3, we have got B, and then H there, and then H there, and then H here. Now, as we can see here, we have said, sorry, boron actually is in group 5. It doesn't have 5 electrons in the outermost shell. Okay, it is in group 3. It is in group 3. It has got 3 electrons in the outermost shell. That was an error. So 3 plus 3 is supposed to give us 6. So this is the compound that boron is going to form. As we can see, all the 6 electrons which were there have been used up. 2 there, 2 there, 2 there. And this is showing that boron has got only 6 electrons in the outermost shell. And it is a balanced atom just like that. It doesn't need anything else, even if it has got 6 electrons in the outermost shell. So for that one, it is an exception to the octet. So another compound that we can talk about is PCl5. Phosphorus with 5 chlorines. Alright. So now if we talk about phosphorus, phosphorus is in group, that is group 5. Group 5, yes. So that is meaning it has got 5 electrons in the outermost shell. And then chlorine is in group 7, telling us that it has got 7 electrons in the outermost shell. But we have got 5 chlorines. So what we are having is to find the valence electrons which are going to participate. So valence electrons will be for phosphorus. How many electrons in the outermost shell? We have said it is in group 5, so it has got 5 electrons. And then we've got 5 chlorines, each with 7 electrons in the outermost shell. So how many electrons are we finding? 5 by 7 and then plus 5. So we are finding 40 electrons So we need to distribute this 40. So what is going to happen is this phosphorus will be the central atom, and then with chlorines around it. So that will be it. Now already these bonds which we can see, there are 5 bonds here. So 5 bonds takes up 10 electrons. So from the 40 we have removed 10 electrons. So the other 30 which have remained, we are going to distribute so that we make sure that these chlorines have got each 8 electrons in the outermost shell. So this chlorine which is here already has it 2 from here, so it needs 6 more. Okay, so we need to put the 6 here. 1 2 3 4 5 6, and then this one 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6, and also 1 2 3 4 5 6. We can find the total. So we have got 6 6 6 6 6, and these are 5, so that will be 30. And we saw that those are the 30 which remained. Now if you consider phosphorus, it is a central atom. It has got how many electrons? 1 2 3 4 5 6 7 8 9 10. It has got an expanded octet. So it has got more than 8 electrons in the outermost shell. That is expanded octet, and it is just fine like that. Okay, so we can look at other examples if you want to draw the Lewis structures. Let's consider oxygen bonded to 2 fluorine molecules, or atoms I mean. So let's find first the electrons. Oxygen has got 8 electrons in the outermost shell, and then we've got 2 fluorines, each with 7 electrons in the outermost shell. So that will give us 14 plus 8, which is 22 electrons. Now because we only have one oxygen, so that will be the central atom, and then fluorines like that. So let's make sure that these atoms which are outside, we balance their octet. So fluorine has got already 2 on the bond, so it needs 6 more. Same with this one which is here, needs 6 more. So this has taken 8, and that is also 8. So how many are remaining? Okay, how many electrons are remaining in this case? So that is 16. Now from 22 we remove 16. So okay. So let's recount the electrons. We've got 2 4 6 8 10 12 14 and also 16. Okay, we have used up 16 electrons, and so we are saying, and the oxygen, this is another mistake I've made. Oxygen has got 6 electrons in the outermost shell, not 8. So these were supposed to be 20. So what we've used up so far are only, okay, we've only used up 16 in these bonds. So from the 20 we are remaining with how many? We are remaining with 4. So these 4 are going to come on oxygen like that. We can, so oxygen has got 2 lone pairs. We can actually calculate the lone pair. Lone pairs is equal to group number, it is in group 6, minus electron shared, it has only shared 2, 1 here, 1 here, and then divided by 2. That will be 6 minus 2, which is 4. 4 over 2, which is 2. So that is the 2 lone pairs. What of fluorine? How many lone pairs are there? So lone pair will be equal to group number, fluorine is in group 7, minus how many electrons has it shared? Each fluorine has only shared 1 electron, over 2. So 7 minus 1, 7 minus 1 is 6. 6 over 2, that is 3. Hence we can see 3 lone pairs on each fluorine atom like that. What of the Lewis structure for C2H2? What would be its Lewis structure? So same here, the first thing we need to identify is how are the bonds going to be formed? Okay, how will the bonds form? So looking at the electronegativities for hydrogen, of course the bonds here, the bonds will be non-polar. Carbon and hydrogen forms non-polar bonds. So the two carbon atoms, first let's find the electrons. Electrons, we've got 2, each carbon has got 4 electrons in the outermost shell, and then we've got 2, each hydrogen has got only 1. That will be 8 plus 2, which is 10 electrons. So it will be first a carbon bonded to a carbon, and then these two hydrogens, one carbon will take up one hydrogen, another carbon, like that. So already how many bonds have we formed? There are 3 bonds, so we only used up 6 electrons. So from the 6 electrons we are remaining with only 4. But remember, we need to balance the octet. If we put those 4, maybe we put 2 here and 2 there, the octet won't be balanced, and so we are going to form a bond here. We make a bond there. So from the 4 which remained, we have formed another bond, and we know that a bond, a straight line, carries 2 electrons, so we are remaining with 2 more electrons. Number, even at this stage, it's not balanced. Octet is not balanced for carbon. As you can see, this is 2, 4, 6. We are remaining with 2 electrons to make 8. So another bond now comes in, and so all the electrons have been used up. So that will be 2, 4, 6, 8 for this carbon. If it is for this carbon, the 8 will be there. So that will be the Lewis structure then for that compound. We can look at another Lewis structure. Let's say when iodine react with 5 phosphorus chlorine atoms. So let's find out how many electrons are there. Iodine is in which group? It is in group 7. So it has got 7 electrons in the outermost shell. Same with 5 chlorines, each in group 7. So that is going to give us 5 by 7, 35, and then plus 7, which is giving us 42 electrons to be shared. So I will become the central atom, and then we've got chlorine, also chlorine, 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 and then another chlorine. So this will be mostly like the same way we did in when phosphorus reacted with 5 chlorine atoms. So to balance the octet, we already have 2 on this bond, so we need 6 more. So always make sure that the octet for those atoms which are around the central atom is balanced. The central atoms, at times they can be below the octet or have an expanded octet. So this will be the Lewis structure. And if you want to count, now the way it is, how many atoms have we used up? We first need to understand how many electrons we've used up. So we have got 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. That should be 38, 40. Is that giving me 42 like that? So that is showing we have used up all the 4. Let me recount that. Okay. So we are saying 5 by 7, 35 plus 7, that is 42. So we have got the central atom and then bonded to chlorine, chlorine, another chlorine, and also another chlorine like that. Okay, so we have got already how many electrons? 2, 4, 6, 8, 10. We have used up 10 from the 42, so we are remaining with 32 electrons. So those 32, let's distribute them. So each chlorine needs 6 more. So from the 32, so we've used up 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So we see that we've only used up 40. What are the other two? Where are they going to go? So those other two will be a lone pair on iodine. If we want to calculate, let's calculate the lone pair on iodine. The group number is in group 7 minus how many electrons are shared. It has shared with 5 things, so 5 electrons have been shared. And then divide by 2. 7 minus 5 is 2. 2 over 2 is 1. So iodine in this case has got 1 lone pair. So those 2 electrons which remain will be a lone pair there. It is different in PCl5 where this didn't have any lone pair. Alright, thank you so much for having watched this video. Have a blessed day.